So we are going to move on to some interesting rules in differentiation, and these rules are important when we have two functions or more than two functions. As the name implies, the first rule is the product rule. So suppose we have two functions and we want to find the derivative of the product. Now, naturally, one might think, let me just write this as, the derivative of f of x multiplied by the derivative of g of x. But this is not true. So we can't simply distribute the derivative like we would do with addition or subtraction. If we're adding a bunch of functions, or if functions are in addition or subtraction, then we could simply distribute the derivative and take the derivative of each function. But we can't do the same thing when we have a product. So we have a rule which is called the product rule. And I like to use a simpler notation. So I am going to call the first function as u and the second function as v. So the derivative of the product of two functions is simply u times the derivative of v plus v times the derivative of u. So, as always, the derivative of v is d over dx of g of x. The derivative of the dependent variable with respect to the independent variable, and u prime is the derivative of the dependent variable, which is f of x in this case, with respect to the independent variable. And this simple rule is what we call the product rule. Now, what if we have multiple functions? So things get tricky. So if we have three functions, f of x, g of x, and h of x, first we've got to find the derivative of that. Using product rule, let's just call it p of x. Then we have to do the derivative of p of x times h of x using product rule again. So if you have multiple functions in product, then we've got to apply product rule multiple times, and things would get really out of hand. The next rule, naturally, is the quotient rule. Now, when do we use the quotient rule? Well, quotient simply means you have one function divided by another function. So, suppose we have two functions So d over dx of f of x divided by g of x is equal, naturally one might think, oh, we'll just take the derivative of the numerator divided by the derivative of the denominator and we'll be done with it. But that is wrong. Life isn't that easy. So once again, I like to use a simple notation. Call the numerator function as u, denominator function as v. So the derivative would simply equal to v u prime minus u v prime divided by v squared. That's v. And as always, u prime is the derivative of the dependent variable. In this case, it is f with respect to x. And the derivative of v prime is d over dx of g of x, which is dv over dx. So here we have a problem where we have two functions in product. So one is x squared plus 1, the other is x raised 5 minus 2. Of course, we can FOIL this and take the derivative, but anytime you have functions in product, it is advised that we use product rule. So I'm going to call that as u and that as v. So u is x squared plus 1, v is x raised 5 minus 2. U prime will then be the derivative of x squared, which is 2x. Derivative of 1 is 0. Derivative of x raised 5 is 5 times x raised 4. Derivative of negative 2 is 0. So the derivative of the function is given by the formula u v prime plus v u prime. That is the rule. So we have x squared plus 1 multiplied by v prime, which is 5 times x raised 4. V is x raised 5 minus 2. U prime is 2x. We have an x in common, so we could pull that x out, which would leave us with 5x cubed times x squared plus 1 plus 2 times x raised 5 minus 2. You don't have to FOIL this and make things complicated. You can leave it as is because it is in quite a compact form. Here we have two functions in product again. So that would be u and that would be v. So does it matter which one you call as u and which one you call as v? Well, it really doesn't matter when we do it with product rule. But you've got to be careful with quotient rule, which is why I like to just keep the numerator as u and the denominator as v, so that we don't have to mess with the formula. But with product rule, it doesn't matter. So u is square root of x, v is x squared minus x plus 1. I am going to rewrite square root of x as x raised 1 over 2. So u prime is 1 over 2, x raised 1 over 2 minus 1, which is 1 over 2 times x raised negative 1 over 2. We can move that x raised negative 1 over 2 to the denominator, it would become x raised positive 1 over 2, and I could write that as 1 over 2 times root x. V prime is the derivative of x squared, which is 2x. Derivative of negative x is negative 1. Derivative of 1 is 0. So f prime of x is u v prime plus v u prime. So u is square root of x. V prime is 2x minus 1. V is x squared minus x plus 1. And u prime is 1 over 2 times root x. Again, it's not necessary to simplify it further in this problem unless you believe that simplification is going to get rid of some terms and simplify it further more than what it is right now. It is best to leave it as is. So here we have an example where I'm starting with u, which might be quite confusing. So u is the dependent variable. T is the independent variable. And I don't want to call the two functions as u and v. Rather, let me call it p and v. So p would be e raised t. V is t raised 1 over 4 minus t raised 1 over 2 plus 1. P prime is e raised t. V prime is 1 over 4 t raised 1 over 4 minus 1 minus 1 over 2 t raised 1 over 2 minus 1. The derivative of 1 is 0. So we have 1 over 4 t raised negative 3 over 4 minus 1 over 2 t raised 1 over 2 minus 1, which is negative half. So the rule in this case, u prime of t is p times v prime plus v times p prime. So p is e raised t. V prime is 1 over 4 t raised negative 3 over 4 minus 1 over 2 t raised negative 1 over 2. V is t raised 4, t raised 1 over 4 minus t raised 1 over 2 plus 1, and p prime is e raised t. We have an e raised t in common, so I could pull that out, and I would simply have 1 over 4 t raised negative 3 over 4 minus 1 over 2 t raised negative 1 over 2 plus t raised 1 over 4 minus t raised 1 over 2 plus 1. Another tricky one involving u. So in this case, u is the independent variable. G is the dependent variable. So let's call that t and let's call that v. I'm trying to introduce variety so that you understand things better. So G prime of u was equal to T V prime plus V T prime. So T is square root of u, which is u raised 1/2. V is e raised u minus e raised negative u plus 4. T prime is 1/2 u raised 1/2 minus 1. V prime is e raised u. We know the derivative of e raised negative u is negative e raised negative u. And the derivative of that constant is 0. So we have e raised u plus e raised negative u. I can rewrite T prime u raised 1/2 minus 1 is negative 1/2. Move that u raised 1/2 to the denominator. I'd have 1 over 2 times square root of u. So G prime of u would be T, which is u raised 1/2. V prime is e raised u plus e raised negative u. V is e raised u minus e raised negative u plus 4. And T prime is 1 over 2 root u. So the answer would simply be square root of u times e raised u plus e raised negative u plus e raised u minus e raised negative u plus 4 divided by 2 square root of u. So here we have a function divided by a function. So f is the dependent variable. T is the independent variable. And as I said, with product rule, doesn't matter which function you call as u and you call as v. It's not a big deal. But if you choose to switch v and u in quotient rule, you've got to be careful with the formula. I like to simply call the numerator as u and the denominator as v, so the formula is consistent. So u here is square root of t minus t. V is e raised t. We are going to take the derivative of u with respect to t. So square root of t, I could write it as t raised 1 over 2 minus t. U prime is 1 over 2 t raised 1 over 2 minus 1. Derivative of t is negative 1. So we have 1/2 t raised negative 1/2 minus 1. Move the t over negative 1 over 2 to the denominator. We have t raised positive 1 over 2 minus 1. And I could write that as 2 times square root of t minus 1. V prime is simply e raised t. So the formula here is f prime of t is v u prime minus u v prime divided by v squared. V is e raised t. U prime is 1 over 2 times square root of t minus 1 minus u is square root of t minus t. V prime is e raised t. We divide it by e raised t squared. We have e raised t in common, so we could pull that out. And that would give us 1 over 2 square root of t minus 1 minus square root of t minus t divided by e raised t squared. We could cancel those two, which would give us 1 over 2 square root of t minus 1, distribute the negative, negative square root of t plus t divided by e raised t. So this one is going to get lengthy because we have to find the second derivative. Notice the independent variable is s, the dependent variable is g. I'm going to call the numerator as u and the denominator as v. So let's find the first derivative on the left-hand side. U is square root of s plus s. V is square root of s minus 2. We have seen multiple times that the derivative of square root of t is 1 over 2 square root of t. So the derivative of square root of s is simply 1 over 2 times square root of s. The derivative of s is simply 1. Same argument applies. The derivative of square root of s is 1 over 2 square root of s. The derivative of negative 2 is 0. So the first derivative of g of s, which is g prime of s, is v u prime minus u v prime divided by v squared. So v is square root of s minus 2. U prime is 1 over 2 times square root of s plus 1 minus u square root of s plus s. V prime is 1 over 2 times square root of s divided by v prime, v squared. It is best to simplify in this problem, or else it is going to turn into a mess. So I'm going to distribute and see if things would get cancelled. So square root of s times 1 over 2 times square root of s. I'm foiling the first two terms here, that term and that term, plus square root of s minus 2 times 1 over 2 square root of s minus 2 minus square root of s times 1 over 2 square root of s plus s times 1 over 2 square root of s. Divided by square root of s minus 2 squared. So those two will get cancelled. Those two would get cancelled. And we will have square root of s minus, the 2's would get cancelled, 1 over square root of s minus 2 minus 1 over 2 plus The s in square root of s, if we simplify and cancel, we would have square root of s divided by 2. And divide the entire thing by square root of s minus 2 squared. Distribute the negative and simplify. We have square root of s over 2. That would equal to 3 square root of s over 2 minus 1 over square root of s minus 2, square root of s. Distribute the negative in, so we have square root of s minus square root of s over 2. So we will have square root of s over 2 minus 1 over square root of s. Negative 2, negative 1/2 is negative 5 over 2 divided by square root of s minus 2 squared. You can see that the original expression, the quotient rule, was that term, which was quite large or long, but once I simplified, I ended up getting a simpler version, which is right here. And since we are trying to find the second derivative, we shouldn't make things complicated. So now we can move on to the second derivative. So g double prime of s would be the derivative of the function we just found. So let's call that u, and let's call that v, which is the first derivative. So once again, this would be v u prime minus u v prime divided by v squared. U, in this case, is square root of s over 2 minus 1 over square root of s minus 5 over 2. V is square root of s minus 2 squared. U prime is 1/2 times the square root of s is 1 over 2 square root of s. The derivative of negative 5 over 2 is constant. Let me rewrite this so that we can follow it better. Move the square root of s to the numerator. It would become s raised negative 1 over 2 minus 5 over 2. Now we know the derivative of square root of s is 1 over 2 square root of s. The derivative of x raised negative 1 over 2 is negative 1 over 2 s raised negative 3 over 2, and the derivative of negative 5 over 2 is 0. The only way we could find the derivative here, square root of s minus 2 squared, is to FOIL. Later on, there is a thing called chain rule, which would make things easier for us. So square root of s times square root of s is simply s. Square root of s minus 2 is negative 2 square root of s. So we have another negative 2 square root of s. Negative 2 times negative 2 is positive 4. So v is s minus 4 square root of s plus 4. Now, we just rewrote v. We have to find v prime. So v prime, the derivative of s, which is 1. Derivative of square root of s is 1 over 2 square root of s. And the derivative of 4 is simply 0. So I could cancel those two and write it as 2, 1 minus 2 square root of s. So v prime is 1 minus 2 square root of s. U prime is 1 over 4 square root of s plus 1 over 2 s raised negative 3 over 2. So g double prime of s is v, which is square root of 2, square root of s minus 2 squared, which is right over here. Oops. V multiplied by u prime, which is right there. Minus u, which is the giant expression over here, multiplied by v prime, which is right here. And the entire thing divided by square root of s minus 2 squared. That is just v, and we have to square it again because v is square root of s minus 2 squared. So we may leave this as is, the denominator, but this is the same as square root of s minus 2 raised 4. A key lesson to learn here is to simplify at this step. And if you thought that finding the second derivative the way we did is complicated, it would have been 10 times harder if I didn't simplify the first derivative to that form. Certainly, this was a complicated and challenging problem. So here we have f, which is the dependent variable. T is the independent variable. The numerator is u, the denominator is v. So u is 1, v is t raised 4 minus t squared. U prime is 0, v prime is 4 t raised 3 minus 2t. So f prime of t is simply v u prime minus u v prime divided by v squared. So v is t raised 4 minus t squared. Luckily, u prime is 0, u is simply 1, and v prime is 4t cubed minus 2t. Divide the entire thing by v squared, which is t raised 4 minus t squared plus 1 squared. So the first term would become 0 minus 4t cubed minus 2t divided by t raised 4 minus t squared plus 1 squared. We have a 2t in common, so minus, if I pull 2t out, I'll have 2t squared plus 1, minus 1 divided by t raised 4 minus t squared plus 1 squared. Again, we have to find the second derivative here. Hopefully this is an easier problem. I think it is going to be. Y is the dependent variable. T is the independent variable. I'll call that U. I'll call that V. So the first derivative U is e raised t, V is 1 plus e raised t, U prime is e raised t, V prime, the derivative of 1 is 0, derivative of e raised t is e raised t, so we simply get e raised t. So y prime is equal to v u prime minus u v prime divided by v squared. V is 1 plus e raised t. U prime is e raised t. U is e raised t. And v prime is e raised t divided by 1 plus e raised t squared. Again, think about it anytime we move on to higher order derivatives, just simplify first. So FOIL the first term here. So we have 1 plus e raised t times e raised t is e raised to t. Same applies in the second or the third term. E raised t times e raised t is e raised to t divided by 1 plus e raised t squared. Those two would get cancelled and we'd simply have 1 over 1 plus e raised t squared. And it just became simple. We could move on to the second derivative now. We have to treat the numerator as u, denominator as v. U is 1, v is 1 plus e raised t squared. U prime is 0. Again, later on there is a rule called chain rule, which is going to make the derivative or finding the derivative of 1 plus e raised t squared to be easier. But as of now, we're just going to FOIL this. And if I FOIL, I have 1 plus e raised t plus e raised t plus e raised t times e raised t, which would give me 1 plus 2 times e raised t plus e raised to t. So the second derivative is v u prime minus u v prime divided by v squared. So v is 1 plus e raised t squared. U prime is luckily 0. U is simply 1. And we haven't found v prime. So I guess I'll do it here on the side. V prime, the derivative of 1 is 0. The derivative of e raised t is e raised t. I will just make a statement and later on you will see the derivative of e raised to t is 2 times e raised to t. Again, that is based on chain rule. You just have to take my word for it for now. When we get to chain rule, you can come back here and verify this. The derivative of e raised to t is 2 times e raised to t. So v prime would now be 1 plus 2 e raised t plus e raised to t divided by 1 plus e raised t squared. The first term would become 0, so we have minus 1 plus 2 e raised t plus e raised to t divided by v is 1 plus e raised t squared, and in the formula we have v squared, so we have to square the square, and we'll have 1 plus e raised t raised 4. So the key things to remember with product rule, quotient rule, is that with product rule, it doesn't matter whether you change the v and the u, the rule pretty much will remain the same. But as far as quotient rule is concerned, I would recommend that you keep the numerator as u, denominator as v, so the formula remains consistent. And anytime you've tried to find higher order derivatives, make sure you simplify the lower order derivatives and then move forward. So in this problem, I first simplified y prime prior to moving on to the second derivative.